Welcome to Pure Mathematics 1, Chapter 7, Trigonometry, topic circular measure. So first of all, we'll look at another unit to measure an angle rather than degree. Usually we use degree to measure the angle like 60 degree or 126 degree or 723 degree. And now we will talk about the second unit that we can use to measure an angle, which is called the radians. So 1 radian is approximately equal to this angle when the arc length equal to the radius of the circle. So this one is equivalent to 57.3 degree. But it's not exactly 1 radian equal to 57.3 degree. It's not exactly that. It's just equivalent. So for a whole angle, which is 360 degree, here, whole angle, this one, the number 360 degree equal to 2 pi radian. 2 pi radians. So now I have 180 degree, so E equal to pi radian. And you know that pi is equivalent to 3.14. Okay. And now we would find the way to convert from radian to degree and from degree to radians. So the way to convert degree to radian is multiply the degree multiply by pi over 180. Let's say the angle pi equal to 60 and we want to convert it into radian. So 60 multiplied by pi over 180 will be equal to pi over 3 radians. Okay, and when we want to convert it back, the radians to degree, and we have the radian, which is also called the angle theta, multiplied by 180 over pi. Let's say my radian in here is pi over 5. My radian is this one. I want to convert it into degree, so I take pi over 5 multiplied by 180 over pi, which is equal to 36 degree. And now we are going to look at the equation or the formula to find the length of an arc of a circle. So first of all, we all know that when you have 1 radian, the arc length would be the same as the radius. So you have radian. Here you have arc length. So when your radian is 1, your arc length will be r, which is the radius. And if you have theta radian, so the arc length will be theta multiplied by r. And now we have the equation to find the length of an arc in a circle. That is that we take the radius multiplied by the radians of that angle. We can be able to find the length of an arc of a circle. Let me take an example here. Let's see. This one, let me assume this one is 110 degree and r equal to 6. So I have my theta equal to 110 degree. So I want to convert it into radians. I have theta equal to 110 multiplied by pi over 180, which is 11 pi over 18. and I have my r equal to 6, so the arc length equal to 6, which is r, multiplied by the theta 11 pi over 18 equal to 11 over 3 pi, which is the arc length of this one. Be the length from here down here. And now we are going to talk about the area of a sector of a circle. So first of all, we need to understand what's a sector first. A sector of a circle is the shape enclosed by an arc of the circle and two radii. Imagine it's like a piece of cake like this. You can have something like this here. This one is called a sector. It's made from an arc and two radii, and it is a part of a circle. When we draw it like this, and you can see here the example here. We have two kinds of sector. The one which is smaller than semicircle is called minor sector, and the one which is greater than semicircle will be called the major sector. You can look at this one, the major sector, which is really big, and the minor sector, which is really small. And now we're going to find the areas of these sectors. This part here, this angle is a theta. So in order to find this area, we will go and find the fraction between the theta over 2 pi. And so why? Because you know that 360 degree, this one, there's a line, this one, 360 degree equal to 2 pi radians, right? So in order to find the areas of a part of a circle, we find the ratio of that part over the 360 degree. In this case would be 2 pi, because 360 degree converted into radians will be equal to 2 pi. And we know the areas of a circle is calculated by taking r squared multiplied by pi. And now we have pi cancel. It will be equal to 1 over 2 multiplied by r squared multiplied by pi. If I say this theta here is a random number I choose, equal to 4 pi over 5. And I have the radius here will be 5, r will be high. So now I want to find the area of the sectors. So area equal to 1 over 2 multiplied by pi squared multiplied by the radians, which is 4 pi over 5. So we will have this one up here is 100 pi over 10 equal to 10 pi, which is the areas of this one. Please bear in mind that we have some other formula to help us to solve questions related to sectors of circles. So you need to know that we have the sine rule, which is this one, and we have the cosine rule, and we have the formula to find the areas of a triangle by using 1 over 2 multiplied by two sides of the triangle multiplied by the sine of the angle in between that two sides. Right here, side B and side A, so we have the sine of the angle in between, which is angle C. I will not go through the topic because this one we learned before getting into P1.